Let's do some dilutions. Welcome to Monroe Tutoring. We're going to jump right into a problem, and then we're going to figure out how to derive the equation that we need, and then we'll always know how to use it going forward. So we have this question, and we're being asked what concentration of aqueous sodium hydroxide, meaning it's a solution, right? So what concentration of this solution will result from diluting 50 milliliters of it at this concentration to 350 milliliters, right? So we have 50 milliliters of this solution. This is its concentration in molarity. And if you didn't catch my videos on molarity, go and check those out so you can understand what we're doing here. And then this is going to be the final volume that we're diluting it to, right? So what is diluting? It's basically when you make something less concentrated, right? So we're taking 50 milliliters of concentrated stuff, relatively concentrated. We're going to add, they don't phrase it this way, but we're going to add 300 milliliters of water to end up with a final volume of the 350 milliliters, okay? Now, if you know the dilution equation, you can just plug these things in, but let's figure out what is the dilution equation, why does it make sense, and if you understand things, it's a lot easier to remember them because it's not just memorization in a void, it's true understanding. So what is happening here? When we are diluting this stuff, we're starting with a certain quantity of the solute, sodium hydroxide, right? We have 50 milliliters of this concentration solution. So there's a certain amount of sodium hydroxide contained in that quantity, right? Then we're going to add water, and it's going to come out to a larger volume, but we're not changing the quantity of sodium hydroxide in it, right? We're just adding water to it. So if you did this in a beaker, and it was originally with 50 mils, and it had a concentration of 5 molars, and then we add 300 milliliters of water to it, there's still the same quantity of sodium hydroxide in there. We're just diluting it, and that's it. So if we look at the molarity equation, as I taught you in those videos, molarity is equal to the moles of the solute over the liters of solution, the volume of the solution in liters, right? Now, we can say that the moles in the initial phase of this problem that we had initially are equal to the moles that we have at the end, right? Because we have a beaker, there's a certain concentration, a certain quantity of a certain concentration stuff, we dilute it, but we don't remove anything, right? And we don't add any of the solute to it. We just add water. So if we solve this for moles, because moles are going to remain the same before and after dilution, we can multiply both sides by volume. And now we can say, okay, the moles is equal to the molarity times the volume. We could also say that the moles at one point in time is equal to the molarity at one point in time times the volume at that same point in time, which is going to be equal to the moles at a later point in time. In other words, the molarity and the volume being multiplied gives us the moles. It's going to be constant. That's going to be equal to the molarity times the volume at the second point in time after we diluted it, right? So in other words, moles before we dilute and moles after we dilute of the solute is going to be the same before and after. That's how we end up with the dilution equation of M1V1 equals M2V2, okay? So this is our main equation when it comes to doing dilution problems, and this is what we're going to use to do this question. So now that we have that, and let me just write it up a little higher over here so we have a little more room. Let's write out that M1V1 equals M2V2. And now we just plug stuff in. So what is the initial concentration, the initial molarity of the solute of sodium hydroxide? Well, that's 5 molars. So we just plug that in over here. So where M1 goes, we're going to plug in the 5.0 molars. And what is the initial volume? Well, we had 50 milliliters of that concentration of stuff. So we're going to put in 50.0 milliliters. Now, remember, when we do molarity and we're trying to calculate molarity, the volume does have to be in liters. But in this case, because we have a molarity on both sides and we have the volume on both sides, the units actually cancel out. So in other words, we can plug in milliliters here. We don't have to convert to liters for this type of dilution problem, okay? If you were given the moles and the volume and you just wanted the molarity, you would have to convert to liters to get the molarity in the correct units in molars. But for the dilution equation, as long as it's like molars here and molars there, and you know, a particular unit of volume here and that same unit of volume there, it's going to cancel out and everything's going to work out, okay? So we have M1 and V1, and that's equal to M2 we don't have, right? Because they say what concentration of this stuff is going to result from diluting it. So we don't know what M2 is, so we just leave it as a variable as M2, and that's what we're going to solve for. So that's going to be M2, and then the second volume is 350 milliliters. That's what we're diluting this to, right? So that's 350.0 milliliters, 0.0 mLs. And now we just have to get M2 on its own. And so just a little bit of algebra. In order to get M2 on its own, currently it's being multiplied by 350. So we have to divide by 350, and whatever we do to one side, we have to do to the other, right? So we're going to divide both sides by 350.0 milliliters. We're going to do the same over here, 350.0 milliliters. And now this whole thing cancels out there, the 350 mils. And then on the other side, we can see milliliters in the top and milliliters on the bottom cancel, which is why we didn't have to convert to liters for this. We just go boom, boom, that's out of here. And our final answer is going to be in molars, which that's good because we're looking for a molarity, right? So let me grab the calculator here. And we're just going to do 5 times the 50, 5 times 50, divided by the 350. And we get a bunch of decimals here. So we have to look at significant figures. If you haven't seen my 2 videos on sig figs, check those out because it's very critical for the entire course and for basically any STEM course. So this has 2 sig figs, that has 3, that has 4. We always have to go with the least amount of sig figs when we're multiplying or dividing. So we're going to use 2, and I'm going to round this, that the second molarity here, M2, is going to be equal to 0.71 molars. And that's it. Now, there's a whole different bunch of ways that they can phrase these problems as long as you take the molarity and volume at a certain point in time and make those M1 and V1 or M2 and V2, depending on when it occurred, everything's going to work out. So you just have to figure out, okay, this volume and that concentration go together. So in this case, those are M1 and V1. And just don't mix them up. In other words, you know, if you use this as your V2 accidentally, this whole problem is going to go south, right? Another thing that you could see is they may have phrased the problem differently. A classic problem is they'll say, instead of writing it the way that I did, they could say, what concentration of sodium hydroxide solution will result from adding 300 milliliters of water to 50 milliliters of the 5 molar solution? So you'd have to really notice that they're saying adding 300 milliliters of water and say, oh, okay, so the final volume here will be the 350, okay? Don't just see the number on the page and assume that you can plug it in. You have to read the verbiage of the problems. So just be careful with that. And that's really it. I mean, dilution problems are really just this simple. So guys, if this helped, please give a like, follow, share, save so you can review again later. And if you'd like to support me further and help me continue making these videos for free, you can check out my links and you can patronize me over there. And that'll help me keep doing this stuff. So guys, thank you. I appreciate it. And I'll see you guys in the next one.